None of this was drawn by hand. 3 equations drawing themselves 1 point at a time. 3 pictures drawn by their own equations. Released 1/100th of a degree apart, now they agree on nothing. Watch it being drawn. 2 rods, the second hanging off the tip of the first, 1 pivot at the top. No motor, no push, only gravity pulling. We let a dozen of them go at almost exactly the same angle and let the lower tip paint where it travels. For the first second, they move as one. Release angle, gravity and crowd size all move. Rainbow chaos, a firestorm, a cyan bloom. The whole recipe. Delta equals theta 1 minus theta. 2 theta diaresis 1 plus theta diaresis 2 times cosine of delta equals minus omega, 2 squared times sine of delta minus 2. G over L times sine of theta 1 theta diaresis 2 plus theta diaresis 1 times cosine of delta equals omega 1 squared times sine of delta minus. G over L times sine of theta 2 theta 1 and theta 2 are the 2 angles. Omega how fast each rod is turning, G gravity. L the rod length. Now look at the left side. Each rod's acceleration sits inside the other rod's equation. They are not 2 pendulums, they are one object you cannot take apart. Four researchers built a real one in 1992 and reported the measurements in the American Journal of Physics. Every extra second you want to predict costs you another decimal place in the starting angle, and the demand climbs faster than any instrument can follow. 2 rods, a hinge, and a wall you cannot get past. No one planted this flower, a cosine did. Watch it being drawn. A point circles the center while its distance from it breathes in and out with the angle. Out to full width, back into nothing, out again. Each time the radius touches 0, a petal closes and the next one opens, tipped a little further around. That is all a rose needs. Change K and the garden changes. Tight trefoils, 8 petal blooms, overlapping woven roses. The whole recipe. R equals a times cosine of K times theta. K is the only number that matters here. Odd K grows exactly K petals, so K equals 5 gives 5. Even K doubles the bloom, so K equals 4 gives 8. Or is just the size. Turn K into a fraction like 5/4 and the curve needs several laps to close, petals crossing over petals. Guido Grandi named these curves Rhodania in 1723, after the rose. He was a Camaldolese monk as well as a mathematician, and he thought the resemblance was worth writing down. 300 years later, we still cannot decide whether they belong to mathematics or to a garden. Nobody can say which wing it will take next. Watch it being drawn. 3 numbers stand in for a slice of air heated from below. How fast it is rolling over, how much warmer the rising side is, how far the temperature has bent away from a straight line. 3 equations say how each one moves next. Step forward a hair, plot the point, repeat. Raise the heating and the wings spread, add paths and the swarm thickens. A classic butterfly, wide wings, a cyan storm. The whole recipe. Letter 1E8b equals sigma y minus x. Letter 1E8f equals x rho minus z, minus yz with dot above equals xy minus beta zx is how fast the air rolls, y how much warmer the rising side is, z how bent the temperature profile has become. Sigma and beta come from the fluid and the box. Rho is the heating and it is the switch. Turn it past about 25 and the rolling never settles again. In 1961, Edward Lawrence restarted a weather run from a printout and typed 0.506, where the machine had been holding 0.506127. 2 months of imaginary weather came out completely different. 2 years later, he had boiled the problem down to the 3 equations above, and this is the shape they draw. One sketch a week, drawn by its own equation. Subscribe if you want the next one.